So we're going to look at sampling errors. This is the last part of the chapter. And these are things that just can go wrong. So before we launch into statistics, before we start doing calculations of means and looking for medians, there are things that can throw off our data. Now, we've talked about this already, and one of the things I'm going to mention is a very sort of powerful non-sampling error. This is not related to sampling per se. Or I'm sorry, this will be a non-sampling issue. So non-sampling errors, this is just human error. So things just go wrong. Examples that they have here, let's take a look. Bad data. Not just bad data, or bad data is pretty serious. But let's say you have good data, you just enter it badly, you record it wrong. Well, that could throw things off. So here, non-sampling means we could have done the sampling right, maybe. But these are errors that have nothing to do with how we put together our sampling, whether a multi-stage sampling or maybe one sampling procedure that we chose. These have nothing to do with it. It's just human error. So going on. Computing errors. Biased. Worded questions. Excuse me. So again, maybe we've chosen our sample really well. We have a sample that reflects the population. Again, biased worded questions could throw off our results. And then this one. So think back to the park example. Let's say they're building a city park in the middle of town and it's near Main Street. So a lot of people are very happy about it. There could be concerts there, could be even maybe a city fair could be there. But then people kind of living near the center of town, where they might hear the concert music, the traffic might spill over into their neighborhood, they might not be so happy about this. But it's kind of becoming popular, at least in the newspapers or maybe local news. So they might not feel comfortable voicing an opinion they think is unpopular. So they might say they support this when they really don't. These are non-sampling errors that can just throw everything off. Now, the two other errors have to do with sampling. Now, one that we know pretty well. We sample but not randomly. So this is examples of this would be like the voluntary response. Or convenient sampling. Here we're not getting a hold of, we're not using randomness to find individuals to put into our sample. Here, oh here. Here in voluntary response, they choose to be in the sample, and then some people choose not to. And then convenient sampling, it's just data or friends that are readily available that we can get information from, and that's it. So it's not random at all. So errors we're getting, Sometimes you've done the sampling right, but human error throws it off. Maybe you're asking the question in a very biased way. Maybe people don't feel comfortable answering that question. Or maybe you're just not doing good sampling. So voluntary response, maybe there's a bias here. Convenient sampling, does your circle of friends really represent everybody you want to, the population you want to study, people you want to get to know what their thoughts are on something? So these are issues. There's one more, and this one is we're talking about these sampling models. You might have thought about this, and we just simply call it sampling error. So with sampling error, this is, you might have thought about this. If we do a random sample, is it possible to get a sample anyway that doesn't represent the population? And it is. It should be very unlikely, but it could happen. So with this case, the sample, it is selected randomly, but doesn't represent the population. The sample is selected randomly, but it doesn't represent the population. So this is a result of chance sample fluctuations. Let me give you an example. Let's say you have a penny. You're going to flip the penny 20 times, heads or tails. Now, generally, on average, you should get half heads, half tails. But it is possible to get 20 heads in a row. Highly unlikely, but it is possible. So that's kind of what you're dealing with here. It is unlikely to get a sample, hopefully, that doesn't represent your population, but it's not impossible. So this might have been something you were thinking about throughout this conversation about, okay, so if it's random, fine, it should be a good sample, but isn't it possible to maybe get a sample that doesn't really represent the population? And it's like, well, that is possible. You were right. So it is something that can happen. All right. The moral of the story is this. Experimental design takes care and thought. This is something, this first chapter, if it feels kind of hard to wrap your mind around some of this stuff, don't feel bad. We're going to get to more formulas later, but this is not easy to do. How do you know you have a sample that represents the population? Well, it turns out even if you do everything right, it is possible that you might not get one. Well, maybe it's not catastrophic, but just a little bit not representative. I mean, that can be a problem too. So this is a topic that it takes a lot of care and thought. You just got to really just kind of work at it, basically. And here, this is what they say. Take the class. There are classes you can take that cover this topic much more in depth. And it's something that, well, it's something that if you're going to go and do statistics, you're going to want to do anyway. So that's it. That's sampling errors. If any questions, let me know.